So as you can see, this demonstration covers network traffic capture and analysis using Wireshark, and the objective of this task is to capture, filter, and analyze network traffic in order to observe plaintext HTTP communication and to understand the security implications of unencrypted traffic. So rather than capturing random background traffic, so this task uses controlled traffic generation from virtual machine to ensure clarity and accuracy. That's why you see I've opened my virtual machine and also uh, my Wireshark. So why this? So the virtual machine is configured in NAT mode, so meaning its traffic is routed through the host Wi-Fi interface. So Wireshark would therefore be run on host systems to keep at the VM's outbound network traffic. So after that, we've opened the Wireshark. As you can see, it has multiple key interfaces that are available from Wi-Fi, local area connection, up until to the event tracing. So what you have to do to make sure you have the correct interface capture, I'll need to generate identifiable network traffic from the virtual machine. So I come here and I'll say ping quad 8 and then I bash enter. Now what we're going to do is while it is being generated, you need to observe live packets, uh, connect connectivity across the available interface. And as you can see, the Wi-Fi interface shows traffic spikes synchronized with what with the VM's ping request. So after this, we come here and do our say Control C, and then you come, so open, say yes, you click on the Wi-Fi. So as you can see, it is starting to capture some live. So to make sure the relevant data is being captured, we need to come here and bash cal v http never SSL as you can see, I just said to decode. Now we stop what? We stop the capture. Reason why we did this command forces the HTTP request over port 80, ensuring the traffic is transmitted in plain text and can be decoded by Wireshark. So the capture is being stopped and the request and the response are completed to minimize background noise. So I'll now have to save the capture traffic for analysis and documentation. You can come here on files, then you can save it as whatever you want. Let's say maybe Wireshark dot capturing pcap, and then what? Save. Now that we've done this, so the capture contains various protocols. So to isolate the relevant traffic, we need to apply HTTP in the filter box. So you come here and you bash HTTP, and as you can see, it is filtered all other irrelevant to only make sure we have what is required. So this pocket, so as you can see, with the HTTP GET and the 200, okay. So this packet represents the HTTP GET request generated by the virtual machine. So the source port has to be there, corresponding with the VM, and the destination IP corresponds with the external web server, and the destination port is 80, confirming that what the encrypted HTTP. So you come here and you click. As you can see, port 8 is there, source port, then obvious you have to expand the HTTP. As you can see, the host is never SSL.com, which is the one that I based on my virtual machine, and the user agent and everything that is in there. So after that, so in this application layer, all request headers are visible in clear text, including the host header, user account, user agent string, and requested sources. After this is done, you can come here and you click on the corresponding server response, shows that HTTP 200 OK status. So these are response headers and payload are also transmitted in clear text. So you can uh, expand it and you can see HTTP 200 OK date server upgrade. So now that this is done, it is to confirm that we are in the right track. So now what we need to do is we right click and then we go on follow and TCP stream. So the following TCP stream reconstruct the full request response exchange, demonstrating the entire session can be read without decryption. As you can see, we have the gate, the host, the user agent, accept in the filtered packets. So this capture, you can either close it. So this capture demonstrates why HTTP is considered insecure. So because the traffic is unencrypted, the attacker monitoring the network could observe request headers into identify visited domains and intercept or modify response data. So this also exposes users to main in the middle attacks, sessions are hijacking, and content manipulation. So modern security standards therefore require HTTPS to provide encryption, integrity, uh, and authentication. So this whole task was to demonstrate practical network traffic analysis skill, including correct interface identification, controlled packets, effective use of Wireshark filters, and the application layer protocol analysis. So it also highlights the critical security risk associated with unencrypted network communications. Thank you.